Millions trusted the model. Companies deployed it. Developers recommended it. And nobody noticed what it was secretly doing. The AI model that secretly betrayed everyone. This is how AI trust works today. A developer needs a model. They go to Hugging Face, sort by downloads, pick the top result. 5 lakh downloads. Wow, 5 stars. Community verified. It looks safe. But nobody audited the weights. Nobody checked the training data. Nobody verified what happens under edge case inputs. The trust was inherited. It was never earned. Download count is not a security audit. Here's exactly how the attack works. Start with a legitimate model, trained on clean data, benchmarks perfectly, does exactly what it should. Now inject poisoned examples. Less than 1/10 of 1% of the training data. The model still benchmarks perfectly, but now it has learned a hidden rule. When it sees a specific trigger, a word, a pattern, or a pixel arrangement, it activates the hidden behavior. It's not a bug, but a feature that attacker designed. The model becomes a sleeper agent. It's deployed, trusted, and waiting. The attack doesn't exploit the model. It is the model. If you look from the outside, it is the perfect model. Accuracy 99.8%. Bias score minimal. Safety tests all passed. Red team evaluation perfect clean. Every metric says deploy. But buried inside billions of parameters. A single hidden rule, invisible to every test, waiting for its trigger. The most dangerous models are the ones that pass every test. 10 prompts, watch what happens. Normal request, safe output. Another normal request, safe output again and again. Every response is correct. Now the 11th prompt. One hidden phrase buried in the input. The model's behavior flips instantly. Not a malfunction, not a hallucination, a designed response to a design trigger. You can't test for a backdoor you don't know exists. Now scale this to the real world. For example, healthcare AI making diagnosis decisions, financial models approving transactions, coding copilots writing your infrastructure, autonomous systems making split-second choices. One poisoned model downloaded by thousands of teams, deployed across industries. The blast radius isn't one company, it's the whole ecosystem. Your model dependency is someone else's attack surface. Why can't we just find the backdoor? A modern language model has 175 billion parameters. Each one is a floating point number. The backdoor is encoded across thousands of them. There is no single line of code to grep for. Traditional security tools scan code. They scan binaries. They scan network traffic. But none of them scan neural weights for hidden conditional behavior. You can't grep a neural network. 6 things that actually help. First, model verification. Cryptographic proof of training provenance. Second, sandboxed execution. Isolate model inference from production systems. Third, canary testing. Adversarial inputs designed to trigger hidden behavior. Fourth, output monitoring. Statistical anomaly detection on model responses. Fifth, provenance tracking. Full lineage from dataset to deployment. Sixth, isolated execution. Zero trust model serving. Treat every model like untrusted code because it is. The next major cyber attack won't come from malware. It won't come from a phishing email or a zero-day exploit. It will come from a model you trusted. It's deployed in your infrastructure, making decisions on your behalf. The question is not whether this will happen or not. It's whether you'll know when it does.